In this video, I'm going to give you some calculator tips that will help you with solving story problems involving sine and cosine. Actually, I like to call them application problems. Story problems sound so Algebra 1-ish and so stupid, actually. Now, when we looked at our Fox problem, the first thing was to write an equation, and we did that in class. And so I have my equation up here, and I'm going to type this equation into my calculator. So here's my equation. I've typed it into the calculator. You may have a slightly different phase displacement or you may have a negative amplitude because we had several different versions of this equation, but they should all be the same graph. Now when I push enter after typing this in, you might want to pause the video a minute and type yours in so you can do this along with me. Okay, you're back now. Notice nothing shows up. And if you think about it, it makes sense that nothing shows up because the smallest fox population was 200 and the largest was 800, and this graph only goes to 6.67. So when something doesn't show up, don't panic, change the window settings. I can go to Menu and to Window and to Window Settings, and I can type in the window settings I want here. 0, I'm going to use 0 for my x minimum because I don't need negative time. I can change the x scale and make it just 1, so that each x tick mark represents 1 unit. My y, I don't need negative y values. I'm going to just go ahead and go from 0 to 900 because that'll cover my 200 to 800 with no problem. And then I'm going to make my scale every 100, I'll have a mark on my y-axis. And if I enter that, notice there's my graph. Now I want to show you just really quickly another way to do that. So if I'm going to undo what I just did and go back to where I was. Another way is if you will click on this, and actually have to click twice I think till it opens up the box. You can also type in your window settings here. So I could type in 900 here, and then if you just push tab, it will take you to the next window setting. Notice how the window setting right here is highlighted around this one, and I like that one the way it is, so I'll leave that one alone. Negative 6.67, I was going to make that 0. And then negative 10, I'm going to make that 0. And that's another way to do your window settings. So 2 ways to do window settings. So notice here I have my equation. I can see what I need to see. Now the first question asks, at 7, 8, 9, and 10 years, what's the fox population? So a really handy way to figure that out on your calculator is to use the trace menu, or the trace function. If you go to Menu, and go to Trace and Graph Trace, notice that you have this cursor here, and as you right arrow or left arrow, the cursor moves around, and as the cursor moves around, notice that down here in the box, or down here F1, this shows you your point. So this is point 4.2 years, 585 foxes. So I can trace along here, and I thought, oh, get to 7. Uh-oh, it just skipped over 7. What do I do? Well, another nice thing about trace is I can type in any x value and push enter, and it will jump to that point. So I'll just type in 7, push enter, and there I am. At 7 years, we have 227 foxes. Type in 8, push enter. There's my value for 8. Type in 9, push enter, and type in 10 and push enter, and I have all. Now notice how the graph shifted over because 10 was right at the edge of the screen, so it kind of shifted it over. And I really want to have my y-axis showing, so I'm going to go back and, I got to escape. Oh, to get out of trace, by the way, push escape. And I want to go over and highlight this and make it back to 0 so I can see where my x-axis was. Well, that's odd. It's cutting the graph off right there. Interesting. Very interesting. Oh, I think because I only had my y-max up to 10. I don't know, maybe if I type in, not 10,000. I've never had that happen before. Sorry, kind of throwing me off. There we go. I just had to change my window setting. I guess when it was reflecting my old window settings on the graph and just cutting it off at 10. So now that I officially changed it to 12, it happily gave me the rest of the graph. Okay, now it's a little trickier when I want to find the answer to the next question, which was about the endangered foxes. It says the foxes are endangered anytime the population drops below 300. So let's trace the graph a little bit and explore this one. If we trace this, and let's find out where the population, so I want to go to where it was first endangered, so I'm going to go back a little bit and say, okay, Right now we're at 300, at 2.1 years, we're at 375 foxes. Then at 2.4, 273. Actually, somewhere in between there, we hit 300. And you might be able to actually get different numbers. Maybe you hit 2.3, which was really close. Some of you, when you trace, you might get 2.3, and you say, oh, that's really close to 300. I'm almost there. And maybe if it was like 2.31, there we go. I can just guess and check and kind of figure it out. And then I can go over here and see when's the next place where it gets above 300, 3.51, maybe I try 3.5. Maybe I try 3.49. Oh, that's pretty good. So it looks like 2.31 and 3.49 would be my answers. And you can do it that way, and sometimes, like in this case, that worked pretty well, just to kind of guess and check and try to figure out what that number is. But there's a way you can go more directly to that number, and that is by using the intersection feature on your calculator. What we want is we want to know when, I'm going to escape out of trace again, we want to know when this equation is equal to 300. So in other words, I would like to find, if I type in a graph for y equals 300, and then I have this graph, and I can see where those two graphs intersect, and those would be my solutions. So push tab, and that will open up your a spot to type in a new equation. I'm going to type in 300. This will give me a horizontal line, and I will know that any time that I get to a place where the two graphs intersect, then that would be a place where y is 300, and so that would give me the x value that where y is 300. So to intersect two graphs on your calculator, you go to Menu, and you go to Analyze Graph, and to Intersection. And you will see this little dotted vertical line, and you're going to take your arrow key, and you're going to left arrow that key over. I don't think you have a point in hand on yours. That's, I think, a feature for the computer software. But move it over until you get to the left of the first point of intersection. And the problem, I can't use my cursor at the same time. The problem calls for me to find the first time that the population drops below 300. So that's why I'm picking this particular curve right here is where the population first drops below 300. So anyway, move your little dotted line over to where it's to the left, and notice it says lower bound. In other words, the boundary to the left, the lower number. Push enter. Now it's going to ask for upper bound, so I'm going to move it to the right, and I'm going to find a point of intersection between those 2 points. Push enter. Notice that point of intersection kind of popped up and labeled it intersection. Now these are the coordinates of that point of intersection. So the point 2.31 years and 300 is that point of intersection. Now if I want to find another point of intersection, I can do this again. Go to Analyze Graph, Intersection, move that dotted line over. I'm going to do it a little faster this time. You'll have to, it's probably a little slower on your calculator. Push enter to set that lower bound, that left bound. Then, I don't know what happened just then. You know what, I'm still in trace. I think I need to escape out of trace. Let's try that again. Menu, Analyze Graph, Intersection. Okay, move this over, push enter, trace it to the right a little bit until I see the point of intersection appear, push enter again, and there's my other point of intersection. So those two features are going to be really helpful if you need to take a value for x and find y, or a value for y and find x. We're going to learn algebraic methods to do that too, but these are the graphical methods. One other thing I want to show you is notice that this graph is labeled f1 of x. Another way I can find function values is to go to a calculator page, and it can't be your scratch pad. It has to be a calculator within this document because it's not, otherwise it won't recognize what f1 of x is. So I'm going to go to Control Doc, open a calculator page. Now notice I can type in f1 of x, or x1 of 7. I want to put 7 in for x, and it gives me the number of foxes. Or I can type in f1 of 8, and it gives me the number of foxes. If I just type in f1 of x, it'll actually show me the equation, although it'll look a little different from the equation that you typed in. And the reason it looks a little different is because I had pi over 2.2 times x minus 5.1, and your calculator distributed the number and put it in decimal form. So the 1.428 is pi over 2.2, and the 7.28278 is pi over 2.2 times 5.1. So your calculator put it in a little bit different form, but it's still the same equation. So there's some calculator tips, hopefully, that'll help you with being able to do some of these problems, and will help you on the application problems.